Hey guys, welcome back. We're going to continue on with capacitors for a few minutes. And what we're going to learn in this lesson is what happens if I connect capacitors in series. How do I calculate the total capacitance? And what about if I add capacitors in parallel? What happens to the total capacitance? Now, the first thing I need to point out is the symbol for capacitance, which I neglected to show you on the last one. It is this straight, usually a straight line and a slightly curved line, or it could be two straight lines. In any case, it's going to be one of the two. All right, so before we start adding capacitors in series and adding capacitors in parallel, I want to talk a bit about this formula right here. And this is a formula that we will never, ever apply, okay? I only want to show it to you so that you understand why we do adding capacitors in series the way we do and why we do adding capacitors in parallel the way we do. Here's the formula. It says here C is equal to A times K over D, and what this is C is capacitance in farads, okay? A is the area of the plates. In other words, you know, the bigger these plates, the bigger A is. K is a constant based on what the dielectric is made out of, and we don't care that much. There is a table in your textbook about what the constant is for each different type of dielectric, and there's a million different types of dielectrics. For the most part, I don't care about this, and neither should you. The other one that we got to talk about here is this D, which is the distance between the plates. So the bigger the distance between the plates, that D gets bigger. Now, if you take a look at this formula really quickly without applying it, if I increase the area of the plates, I will be increasing the capacitance. The number on the top here is getting bigger. That means this number is going to get bigger. But on the other hand, if I increase the distance between the plates, the actual capacitance of the capacitor will be going down. Okay, so that's the relationship I want you to notice. Now, if we're going to add capacitors in series, and let's say I had a 200 microfarad and a 300 microfarad, the question is, if I connect this to a circuit, I'd have like this plate to, pile electrons on to. I'd have this plate over here for electrons to leave from, and there wouldn't be a whole lot going on in between these because whatever electrons would be in there would be moving around a bit. But mostly, if you look at this formula, have I increased the area of the plates by doing this, or have I simply increased the distance between the plates? Now I have two distances here and kind of the same amount of area. So you can see that if I do this, the actual total farads of the two will go down. And so the formula that we use to calculate the microfarads, if I have capacitors in series, is a formula that you will probably recognize from level 1. It is the reciprocal formula. Now, in level 1, the reciprocal formula was used to calculate resistors in parallel. When we're talking about capacitors, we use the reciprocal formula to calculate the total capacitance when we have capacitors in series. Okay, so it's exactly the opposite of resistors, and you're going to notice, going forward that capacitors are always the opposite of everything. Okay, if you do something with one, you're going to do the opposite with capacitors. Okay, so this is the formula that we would have to use. Now, if I transpose that formula, C total will be equal to 1 over C1 plus 1 over C2. And let's try that. It should be 1 over, it should be 1 over all that. It's kind of getting messy here, okay? So 1 over C1 plus 1 over C2. So it's going to be 1 over 200 plus 1 over 300. And I'm going to use the 1 over X button to figure that out. I'm going to go simply type in here 200, hit 1 over X, plus 300, hit 1 over X, hit equals, hit 1 over X, hit equals, and we can see that the total capacitance of these two is 120 microfarads. Okay, guys, so even though 200 and 300, because I've connected them in series, the total capacitance is actually lower. And it's kind of like resistors in parallel. We know that the total resistance of a parallel circuit will be less than the lowest resistor. And it's the same with capacitors. The total capacitance of capacitors connected in series will be less than the lowest capacitor. All right, guys? Now, what about when they're in parallel like this? Well, if you can look at it and compare it to this, now I've got electrons to pile on here, I've got electrons to pile on here, I've got electrons I can leave this plate, leave this plate. So, you know, I'm actually adding a whole bunch of area to the plates. I'm leaving the distance between the plates alone. Basically, I've just created a larger capacitor by doing this. And so the formula that we're going to use to calculate the total capacitance when they're in parallel is C total is equal to C1 plus C2. Now this formula is the same formula you learned in level 1 for resistors in series. So we're going to use this formula here for capacitors in parallel. And so it is going to be 200 microfarads plus 300 microfarads is equal to 500 microfarads. Okay, guys? So, yeah, that's how that works. Talk to you soon.